Alex Reed, CEO and co-founder of Fluence Analytics. Our company is focused on improving the manufacturing and development of new polymer materials and existing polymer materials, so improving yield, cost, efficiency in that process. So one of the things that we've noticed working with different companies over the years was there's still a heavy reliance on offline analysis of properties to either control a process, continuous manufacturing, sometimes at the end of a batch. And so that lag time of information creates an inefficiency in the process and in the manufacturing. And the result is typically off-spec material, some quality deviations, poor control of the process, so maybe you can't produce or scale up exactly the things that you made in pilot scale or lab, and then overall reduced efficiency. And so what we've been able to do is take our hardware and software system and install it in manufacturing facilities, as well as pilot and labs, and monitor the process in real time for critical polymer properties. And so today, we send that information to the control room where an operator can make a controlled decision. And where we're looking to go, and what we've already done some work on, is to do full feedback control of the process. And what we see the opportunity also here is in new material development. So as you're launching new products, having a tighter control, tighter, faster, real-time information of the properties, being able to drive that development and actually produce that material just how you researched it in the process. And so, this is a university spin-out. So we have a long history of work funded by chemical companies, significant amount of grant funding as well. So we're currently at 16 issued patents, and we have 31 pending applications. The 5 issued and 19 pending since 2013 are developed by the company directly. So we've continued to innovate, continued to file patents. And so what we're doing here today is we know there are some chemical manufacturers here. We have several customers already. We're in some plants. We're in pilot facilities. And we raised a Series A. And we're now on the process of gearing up for a Series B. But in the interim, we're really more interested in working with companies to help them optimize the process. So last year, we launched a pilot program where we actually will take our hardware and software to a plant or a pilot facility and run tests to generate data so that we can make decisions. We found this has worked very well. In fact, we ran a pilot in the Gulf Coast at the end of last year, right before Christmas, and we just had a decision recently, last Friday, that they do want to proceed to a plant installation. So we found that this was the easiest, quickest way for us to give somebody proof. Chemical industry likes to know that it works, likes to know that it's reliable, likes to know that it's delivering value. And so what we're looking for are people that have applications they're interested in optimizing, or new applications for development that we can work with them on. And then, as I mentioned before, later in the year we will be doing some fundraising. That'll be primarily to build out some of the software capability and some of the actual hardware and the rest of the team. But on the software side, what we're really looking to do there is process contextualization, because now that we have real-time information, we've already done some work to correlate that to other process parameters. So if you know exactly what you're making in real time, everything else in your plant's already in time series database. So being able to overlay that with other process parameters is a very exciting opportunity. And then finally, team, we can leave this up for Q&A. So the work came out of Professor Wainwright's lab. He's a world-renowned expert in polymer chemistry, or I'm sorry, polymer characterization. Mike Terensky was his director of instrumentation and student, and our CTO. Bill Bottoms, who's in the back there, is a Silicon Valley technologist, has done a lot of investing, entrepreneurship in technology, been very successful, and then I took on the role of entrepreneur, as the entrepreneur. Thanks. Any questions?
Thank you so much. So we got one question here, and then a second from there. Start here.
Yes, so we have light scattering. So these are typical sensors you might find in a lab that we've engineered for online measurement. So we use light scattering, we'll use spectroscopy, We'll use connectivity. So basically, we have the platform to automate the whole sampling and conditioning process. We can put any detector we want there. So our core are those typical ones: light scattering, spectroscopy, refractive index, intrinsic viscosity, conductivity for charged polymers, things like that.
Great. And then we have one more final question.
Yes.
So, are you actually making the instruments that do these things and then providing the analytical solution to that? And who would you say are your chief competitors here?
Yes, first answer is we do make the hardware and the software and the instruments in the system. Chief competitors we've found are a lot of companies have work going on internally to optimize processes, so we've run into different groups that spend a lot of time modeling. What we've seen when we had the opportunity to work with some of these groups, that our sensors actually improved their capability of modeling. That was actually the case in that trial. So I'd say the biggest competition are things that people are doing today with inferential modeling, existing, not wanting to change the offline process. And then there are some in-reactor sensors. We've seen that about a dozen companies, as those have had very limited success with fouling and different issues.
Thank you so much, Alex.
Great.